Who's my favorite student? Well, good old Ann. Number 1 says, given the following point configuration, what can I do with 2 points separated by a distance? Well, one thing we can do is we can find the electric force. Now, the electric force is going to be K Q1 Q2 over R squared. It's going to be 9 times 10 to the 9th. Q1, 5 microcoulombs. I don't put the negative in for force. Q2, 3 microcoulombs. All over R squared. I guess R is 1.5 plus 0.85. I guess R is 2.35. I'll double check that because it's a quiz. And don't forget the squared. I get a magnitude of Is there typos there? It looks good. Do you get 0.02444? Newtons. I didn't ask for a direction. Taryn, I could, but I have to tell you on which charge. Taryn, which way is Q1 feeling a force? To the left or to the right? One of those answers is correct. That's the good news. Let's try that again. Which way is Q1 feeling a force? To the left or to the right? Why? Because unlike charges attract. And Q2 is feeling a force to the left. Okay. What else can I do? B is definitely going to be a written question. I'm going to ask you to find the electric field between 2 charges at a location. How am I going to do that? I'm going to find the electric field from charge 1, magnitude and direction. I'm going to find the electric field from charge 2, magnitude and direction, and then I'll add them vectorially. If they're in the same direction, winner plus winner. If they're in opposite directions, winner minus loser. How do I find electric field? K Q1 over R1 squared. K Q2 over R2 squared. It's going to be 9 times 10 to the 9th, 5 microcoulombs, all over 1.5 squared. 9, you know what? I think I can just backspace and do a little editing here. There's 9 times 10 to the 9th. There's the 5 microcoulombs. I just need to delete that and make it a 1.50 squared. That was easier. And I get 20,000. Is that correct? Newtons per coulomb. Direction. I imagine a little positive at location A, and I ask which way would it feel a force because of charge 1? It would get pulled to the left. I repeat for charge 2, 9 times 10 to the 9th, 3 microcoulombs, all over 0.85 squared. So 3 microcoulombs all over 0.85 squared. And I get 37,370. 37,370 newtons per coulomb. Direction. Which way would a positive charge at location A want to move because of Q2? I think also to the left. So final answer is going to be, I did that wrong, Mr. Duick. Mr. Zero. Add 20,000. Is it 57,400? Newtons per coulomb left. I would give you 1 mark for the magnitude, 1 mark for the direction. Okay. can also ask you to find the electric potential at a location. Now remember, this is not potential energy. This is voltage. So what am I going to do? I'm going to find the voltage from charge 1. I'm going to find the voltage from charge 2. They're scalars, so I'm not going to add them vectorially. I'm just going to add them up. But because they're scalars, I am going to put the sign in. Voltage is KQ1 over R1. And voltage is KQ2 over R2. I can bring back some previous lines. And I can't help noticing that this line here, if I just delete the squared, that's the voltage of Q2. I'm that lazy. It's going to be 31,764. 0.7, 31,765 volts. What about charge 1? I bet you I can, well, I'm just going to type it. It's going to be 9 times 10 to the 9th, negative 5 microcoulombs divided by 1.5. So I am going to include the negative. It's going to be a negative voltage. And I get negative 30,000 volts. The total voltage at location A, I guess it's just going to be positive 1,765 volts, 1,770 if you went to 3 sig figs. I would give you half mark for the negative 30,000, half mark for the 31,765, and then 1 mark for adding them together. So that's a few of the things that I can do with point charges that are separated by a distance. What else? Well, suppose we have a fixed charge of magnitude Q1. How much work would it take to move an electron an extremely large distance away? I decided to dulp here. So I said, here is my big charge Q1, and it's negative 8 microcoulombs. And then I imagined, I guess we're moving an electron that way. How much work? Oh, this is easy, because work is force times, wait a minute, why can't I use force times distance here? Because the force is changing. So it's going to be the change in potential energy plus the change in kinetic energy. I don't see any mention of speeds, so I'm going to assume that we start and end at rest. Zach, what's change in anything? So the change in potential energy is going to be, I guess, K, well, you know what? I would go like this. Potential energy final minus potential energy initial. This is actually a little better. Starting from a very long distance away, that's out at infinity, I can say you had no energy out there. So I actually end up with K Q1 Q2 over R. Final. It's going to be K, 9 times 10 to the 9th, Q1, negative 8 microcoulombs, Q2, it's an electron, negative 1.6 times 10 to the negative 19, all divided by 0.15. You'll notice I get a negative times a negative, which is a positive answer. Yeah, I would have to do work, because does this electron want to move to the right? No, it's being repelled the whole way. So on a microscopic level, you would be pushing and pushing and pushing and pushing, like lifting an object up. You are doing work against a force. It's going to be 9 times 10 to the 9th, negative 8 microcoulombs, negative 1.6 microcoulombs divided by 0.15. Check for typos. That looks good. Did y'all get 7.68 times 10 to negative 14? Joules. I would give you 4 out of 4 for that. Otherwise, I would probably go something like 1 mark for that, 1 mark for that, 1 mark for the numbers, and 1 mark for the answer. Then I would turn the page. Ooh. Gabor, what do they want me to find in number 3? Did they say how much work? Oh, you know what? This is like falling. This is like conservation of energy, Gigi. We're falling up, but that's okay. So I'm going to start out by going KE initial plus PE initial equals KE final plus PE final. We're starting at rest, but you know what? Our energies are potential and final. None of those are 0. So it's going to be K Q1. I'm going to call this Q1. I'm going to call the proton Q2 over R initial equals a half M V final squared plus K Q1 Q2 over R final. I'm not going to get the V by itself yet. I am going to minus this over to this side, and so I'll get a half M V final squared equals K Q1 Q2 over R initial minus K Q1 Q2 over R final. This is a bit weird because I'm used to final minus initial for change in. I guess this is a negative change in. I'm not going to worry about it. It's definitely initial minus final. So, a half little m v final squared equals k, 9 times 10 to the 9th. Q1 was 5.5 microcoulombs. Q2, it's a proton, positive 1.6 times 10 to the negative 19, divided by R initial, 1, minus same thing times same thing times same thing, all over R final. What's R final? It's not 2.5. 3.5. Common mistake kids make is they just go, that's R final. No. From the fixed charge, 3.5. 3.5. So, I'm going to get a half little m v final squared equals 9 times 10 to the 9th times 5.5 times 10 to the negative 6 times 1.6 times 10 to the negative 19 divided by 1. I didn't need to type that technically, but I'm going to reuse this. So I get 7.92 times 10 to the negative 15, and then minus, repeat, but with a 3.5 there, 2.262, I'll go 2.263 times 10 to negative 15, because I'm going to use my answer button. It's going to be 7.92, scientific notation, negative 15, plus answer button. Not plus, Mr. Dewick. Minus, that would have been silly, minus answer button. And I get 5.657 times 10 to the negative 15. Now what? Now I can get the V by itself. Times by 2, divide by m, square root. Times by 2. Divide, m. It's a proton. $27? Square root. 2 times answer button divided by 1.67 times 10 to the negative 27. Square root of that. And I get a final speed of 2.60 times 10 to the 1, 2, 3, 4, 5, 6. Is that right? People nodding? So if you got that, 4 out of 4. Otherwise, by the way, I'd probably make this a 7-mark question on the written section of your test because it's a lot of work. Otherwise, I would probably go half mark for that, half mark for that, half mark for that, half mark for that, half mark if I saw that, half mark if I saw that. What am I up to? 1, 2, 3. Then I would probably go half mark for that and a half mark for the answer. Something like that. Number 4, what's the closest it can get before coming to a stop? Is this asking how much work? No. So, conservation of energy. And it looks like we're coming to a stop, so I can do that. Did we start from a very long distance away? Oh, it'd be nice if we did, but I guess not. So it's going to be a half m v initial squared plus k q1 q2 over r initial equals k q1 q2 over r final. Instead of going Q1, Q2, I decided to go big Q for the planetary charge, little q for the electron, little q for the electron, whatever works. What am I trying to find? I'm not going to get that by itself. I'm going to crunch the whole left-hand side first. It's going to be 0.5 9.11 times 10 to the negative 31, and its speed was 6.8 times 10 to the 6th, don't forget the squared, plus 9 times 10 to the 9th, negative 5.5 times 10 to the negative 6th. It's an electron, negative 1.6 times 10 to the negative 19, all divided by 5. That equals, need more room, Mr. Duick, K, big Q, little q over R final. 0.5 times 9.11 times 10 to the negative 31 times 6.8 times 10 to the 6th, don't forget the squared. And I get 2.106 times 10 to the negative 17. 9 times 10 to the 9th times negative 5.5 times 10 to the negative 6 times negative 1.6 times 10 to the negative 19 divided by 5. Typo, Mr. Duick. Where is that? So that's 9 times 10 to the 9th. And then I need to insert a times sign there. 9 times 10 to the 9th times negative 5.5 micro times negative 1. Good. I get 1.584 times 10 to the negative 15. That equals K, big Q, little q over R. I'm going to add 2.10622 times 10 to the negative 17. It's not going to make a big difference. That 10 to the negative 15 is going to dominate. And I get 1.605 times 10 to the negative 15. 1.605 times 10 to the negative 15. That equals K, big Q, little q over R. Where is the R right now, Braden? On the stuff moves diagonally. Now I would do that. So now I would say, okay, R final is going to be K, big Q, little q, all over 1.605 times 10 to the negative 15. I hope this is going to work. It's going to be I'll write out the numbers, Mr. Dewick. It's a quiz. 9 times 10 to the 9th, negative 5.5 microcoulombs, negative 1.6 times 10 to the negative 19 coulombs, divided by 1.605 times 10 to the negative 15. Look for typos, Mr. Dewick. I think that looks good. Do you get 4.93 meters? Whew. If you got that, I would give you 4 out of 4. Otherwise, in terms of part marks, probably something like half mark for that, half mark for that, half mark for that, half mark for that number, half mark for that number. 1, 2, 3, 4, 5. Half mark for that, half mark for that, and a half mark for the answer. Can you give yourself a score, please, out of 18?